Hello guys, welcome back to this channel. I hope all of you are doing well. In this video, we are going to discuss about how to merge small HDFS files in Spark. Let's take an example of Spark SQL here. We know that by default there are multiple files are created during our batch processing in Spark. If we see here, we are picking the data from table 1 in database 1, and then you apply few queries and you register it as a temporary table. Suppose the first temporary table was created as temp table 1, and then you apply few more operations on temp table 1, and following the lineage you create temp table 2 and so on, and finally you have a temp table final. Now at the time of writing your final data set into a permanent hive table, which is your table 2 in the database 2, you are using insert into statements. So what you will do is you will fire an insert into this table statement and select star from this table, because this is the data which is created through this process for today, right? Now this new data gets written into this table 2. But guys, what do you think? What will happen once we perform this final statement? So the answer is there will be multiple files created under table 2, and each file will have some size, right? So there are number of partitions which are created at the time of writing your final data, right? Suppose this was the last statement. So what it will do is in this table 2 it will create several splits of the final data. Suppose my table 2 was empty, and this is the data which got inserted into this final table, right, which is table 2 under database 2. Now if you monitor it closely, there are multiple splits created here, and if we see this, if we sum up this size, this will come across as 4 MBs of data, right? There are four files created and overall size is 4 MB. Now we know for sure that our block size or HDFS block size is 128 MB. Okay, suppose my cluster is such where my block size is defined as 128 MB. Now we know for sure that these four splits of data can be a single file and ultimately a single block in HDFS, right? Rather than creating separate splits, we should be doing this in a single file, right? And which is also called a single partition at the time of writing into table 2. Right now, why do we need this? Why can't we have multiple splits, and why it is recommended that you should have only a single file? Looking at the size, which is around 4 MB for overall all of these files, the reason behind it is, if you create multiple files of small kbs, right, on daily basis for a hive table, right, you will be accumulating too many files, right? Suppose for first day you create these 4 files, on 10th day you will be getting around 40 files, and then so on, right? So ultimately on daily basis you are getting more than expected, and then what it ultimately does is it increase your hive metadata and your name node inventory, which you don't want, right? Remember the HDFS thumb rule, you shouldn't have multiple too many small files, right, in HDFS. Rather than HDFS is meant for large files, right? Now, another reason why you should have only single split rather than multiple partitions while writing your final data is it impacts the performance of your batch jobs due to slow network input output speeds. Now, imagine that you are reading the data from table 2 for your next job. Suppose your job number 3 is reading the data from your table number 2 in database 2. Now, obviously, if you have too many files to read it from the metadata, it becomes difficult for the network input output, right? There are so many jobs running in your cluster, and ultimately it slows down your batch jobs, right? Because if you have less number of meta splits, which ultimately results into lesser inventory, it becomes easy for your job to read those splits, right, rather than reading those too many splits from a number of HDFS locations, right? Because in your cluster, in your yarn cluster, you have number of data nodes, and which split is placed at which location, that also it has to find out. So it goes like that only, that it ultimately slows down your batch jobs performance, right? Now, how to tackle this situation and how to overcome from this? So the answer is very simple, that you have to use some kind of repartitioning strategy. So coalesce is a function which normally solves your this kind of problem, which means it doesn't do a whole shuffle at your in your job, and it brings all the data into single partition, right? And then at the time of writing the data into your final table, it makes sure that in the previous step, when you prepare the temp table final, you write all the data into a single file or single partition, I would say, into the temp table final, and that temp table final is getting written into the final table. So ultimately it writes only one file. Now how it looks like, it looks like this only, right? Remember, earlier you had four files, right? And now the size is still 4 MB, right? But the data is written into only one file, right? The size is 4 MB around, right? And the data is written into only one file. This is what we want exactly, that all the files, multiple files which were created by default, are getting merged into a single file now, right? Which solves your purpose.